Hello, this is Unit 3, Lesson 2, Video 3 for Chemistry 1. So we have been talking about what is an atom, and we have looked at Dalton's atomic theory and how it has changed. So today's definition of an atom is the smallest part of an element that still retains the element properties. So in our modern atomic theory, we said that atoms are divisible and can be destroyed. So that means that there are things that make up the atom. And that's what we're going to look at next. So on the next page, we can see that we have three parts of the atom: the electron, the proton, and the neutron. And what we're going to do is we're going to go through and look at who discovered these parts, how they did it, and a little bit of information about each particle. There are going to be several YouTube videos that I would like you to watch that are in the Schoology folder that pertain to these experiments. So our first particle is the electron, and the person who discovered it is J.J. Thomson. And he discovered it in an experiment called the cathode ray experiment. Cathode ray tubes are going to be a physical structure, and if we were in person, I would be able to show you what one of these looks like because I have one in my classroom. And the video that I show that's on YouTube is going to demonstrate how this actual experiment worked and what J.J. Thomson did. So this was back around the turn of the 20th century. So we're looking at the late 1890s. So we knew that these particles were there, and they used something called indirect observation. And I'm going to write that up here. So we can't see, or they couldn't see a lot of these things. So they had to use evidence that was not directly observable. So they did something and it caused something else to occur that proved the existence of the particle. And we do this all the time. So if we were in a completely dark room and we had to feel around the wall for something, we know that there's something there, but we can't figure out what it is. We can use indirect observations to figure that out. Or if you had a box that had objects in it, you might shake it to try to figure out what's inside by using indirect observation. So you might be able to figure out the shape of something based on how it moves. So that's what indirect observation is. So these electrons were observed, and they used this cathode ray experiment. And this column here, we're just going to use as a reference. You do not need to know the actual mass of these, but I just put it in here so you can see how small these things are. And the actual mass of an electron is determined to be 9.11 times 10 to the negative 28 grams. So it's something that we really can't measure, but we can use, again, indirect observation to calculate the mass of an electron. We'll save this one for later, the relative mass, because this is what we're going to use to compare things. So we're actually going to define something and then judge the mass of an electron, a proton, a neutron based on this substance. And we all know that the charge of an electron is negative, and it's located in the electron cloud. So surrounding the nucleus. The proton was the next particle to be discovered. And Ernest Rutherford is the person who discovered the proton. He first discovered the nucleus and then later on discovered the proton. And the experiment is the gold foil experiment. And I have two videos in the Schoology folder for you to watch on this. There's one that's an animation and one that's a recreation of this. And you can see how this gold foil experiment worked and how they were able to figure out the existence of the nucleus, and then the proton. The actual mass, 1.67 times 10 to the negative 24th grams. So you can see that it's a lot bigger than an electron, but it's still really, 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 really small. Its charge is positive, and it's located in the nucleus. So the neutron, very, very hard to figure out that this was there. These two up here have charges. So we could use that fact because if something had a like or an unlike charge, it would either attract or repel these. But the neutron is neutral. So it was really hard to detect or come up with an experiment. And the person who came up with it was James Chadwick. And he used something called the beryllium experiment, and you are not responsible for that one. It's pretty hard to explain. And he was actually a student of Rutherford's that was working with him on this. And what they found is, well, this nucleus, there has to be something else there, but they couldn't detect it using other means, so they had to come up with a way to detect it. And they did using radioactive materials. And the actual mass of this is 1.675 times 10 to the negative 24th grams. So it's very close in mass to the proton. Both of these are so much bigger compared to the electron, and its location is also in the nucleus. So coming back to this column, the relative mass, this is going to set the relative mass of particles by comparing them to a set standard. So we have to define something, just like we did in the metric system. We would define what is a meter, what is a liter. Well, this unit is called an atomic mass unit. And the standard is 1 AMU is equal to 1/12 the mass of carbon-12. And carbon-12 is an atom of carbon. So 1/12 the mass of carbon-12. And what that does is it sets the proton and neutron at 1 AMU apiece. Because remember that their masses are very close to one another. Now, if we tried to compare an electron to these, we would find that the relative mass is insignificant when compared to a proton or neutron. That's because this one is like 10,000 times smaller in mass than these two. So we say that this one is insignificant when compared. So things that you should know the experiment and discover relative mass, charge, and where these are located.